when we ended the last video, we were talking about growth hormone problems. We said that hypersecretion in children results in gigantism, which meant that the growth plate hadn't closed. Hypersecretion makes the kid get larger. And so if he's in the third grade, it might look like he's in the seventh. After the growth plate is closed and oversecretion of growth hormone, most of the time it's a pituitary tumor, will create something called acromegaly. The person will be somewhat large, but the growth plate, so once it is closed, then the bones cannot get any longer, but they can certainly get what? Thicker. So you'll have a jutting mandible, big hands, big feet, things of this nature here. All right. Now, hyposecretion can cause dwarfism. I want to point out on dwarfism, the types of dwarfism. One is called achondroplastic and the other is pituitary. The one due to growth hormone is pituitary. So the person is small, but the relative size of all of the parts of the body are just small, but they're all proportional. See, proportional dwarfism. Achondroplastic dwarfism, where there's a problem with cartilage converting to bone, is where certain parts will be abnormal proportions to the body. So the two major types are pituitary and achondroplastic dwarfism. But the one of our interest in this is this one here. This is caused by a different problem. Okay? So let's go further. Here again is the growth hormone, but we've talked about that. All right, now we're going to thyroid-stimulating hormone. We're now going to thyroid-stimulating hormone. Okay, the way this works, the hypothalamus releases thyroid-releasing hormone. That goes to the anterior pituitary. The anterior pituitary, then the thyrotrophs of the anterior pituitary have receptors for thyroid-releasing hormones. So at the anterior pituitary, that causes thyroid-stimulating hormone to be released. Thyroid-stimulating hormone goes to the thyroid gland to cause production and secretion of thyroid hormone, which are called T3 and T4, triiodotyrosine and tetraiodotyrosine. See, thyroid hormone is made up of a tyrosine aspect. Remember we said it was an amino group, amine type. Okay, but there's negative feedback. So the more thyroid hormone, the more negative feedback on the anterior pituitary to lessen and the hypothalamus. So it works on many areas of the body. Thyroid hormone does many areas of the body. Let's look here. So what we're looking at then, thyroid stimulating hormone release. Okay, here's thyroid hormone. Thyroid releasing hormone will come down, hypothalamus, go to the anterior pituitary, thyrotrophs. The anterior pituitary will secrete thyroid stimulating hormone. That will go to the thyroid gland and cause the production and release of T4 and T3. These are the two thyroid hormones, T4 and T3, and so forth. And these hormones, because these are really should be water soluble, but slightly lipid soluble because of the way the biochemistry is, then you have in the blood something called a thyroid binding globulin, the TBG, and so forth. Okay. All right. So this is what we're looking at. All right. So and thyroglobulin. See, there's a thyroid-binding globulin, then thyroglobulin is in the thyroid gland, which acts within the thyroid gland to store these particular hormones there. Okay, so here again is that. Come down. Now the next one is adrenocorticotropic hormone, and that particular hormone is secreted by the corticotrophs of the anterior pituitary and stimulates the adrenal cortex. So here is this hormone, ACTH, goes to the adrenal gland, and the adrenal gland, let's come back here. Here's the adrenal gland, also in England called suprarenal gland. It's on top of the kidney. That's why it's called adrenal, added to the renal, or suprarenal. It has two portions, the cortex and the medulla. The medulla, recall, does epinephrine. We said the sympathetic nervous system was associated. The cortex has three layers, the zona glomerulosa, fasciculata, and reticularis. Here's the medulla. The zona glomerulosa primarily is responsible for secreting something called the mineral corticoids. The mineral corticoids that's secreted from there. Okay. The zona fasciculata does the glucocorticoids. The glucocorticoids would be like cortisol and so forth like that. Cortisol. And then the reticularis produces things that are more male hormone, androgenic in nature. So three zones, they all are producing different things, okay? All producing different things, and that's what we're looking at. So it stimulates the adrenal cortex to release corticosteroids. So all the hormones coming from the adrenal cortex are steroid. So collectively, they're called the corticosteroids. So again, all of them are steroids. Zona glomerulosa produces primarily, like I said, the mineral corticoids. Primary one is aldosterone that we talked about, aldosterone. Zona reticularis, primarily cortisol, and these mainly male hormones there. The ACTH mainly works on this layer. The mineral corticoids are mainly being controlled by osmotic pressure and other things there we talked about. Aldosterone is the sodium retaining hormone, so it also works in accordance with more of a humoral, dealing with the sodium level and so forth, and potassium. Potassium actually stimulates it more. This one is really the one listening more to the ACTH than anything. This slightly, but not as much as this one. All right, we go further. So regulation triggered by hypothalamic. I'm going to go back to this picture. Triggered by hypothalamic release of corticotropin releasing hormone and other factors like we said, stress can offer. Cortisol is your anti-stress hormone, and it is also your anti-inflammatory hormone. Let's just bring it. It's your anti-stress and anti-inflammatory hormone. Okay. All right. We go further. Then we come to the gonadotropins, and again, as I alluded to there, we won't talk much on that except for the fact that we can say that the gonadotropins, we'll talk more in the reproductive, but the gonadotropins, gonadotropin releasing hormone will go to the anterior pituitary, which then can secrete LH, luteinizing hormone, FSH, and then it can go and work on the ovaries and also the testes. Okay, so we'll talk more about that in the reproductive, but that's the gonadotropins. Okay, all right. Then we go to prolactin, and again, that's something that we'll be talking more about in the reproductive. But prolactin is the hormone that makes the milk. Oxytocin causes the letdown. TRH has some influence, a positive influence, but most of the control, that's what we're going to say here, is controlled by PIF, called prolactin inhibiting factor. But what we found is prolactin inhibiting factor is dopamine. So dopamine causes prolactin to decrease its production. But we'll talk more on that in the reproductive as to how prolactin will stimulate the breast to do the milk production and so forth. So again, we'll discuss that more. But prolactin associated with milk production. Think about that. Prolactin associated with milk production. And here's prolactin. Primarily controlled by prolactin inhibiting, some call it PIH, most call it PIF, prolactin inhibiting factor, which is dopamine, and so forth. And we'll talk more about that as I alluded to there. So we'll close right here.